Welcome to Chapter 12 for the research methods for exercise science, sports medicine, and fitness technology students. Screen shared. We'll get rolling in this chapter. It's a short one, but it's got some stuff in here that'll take a bit of explaining, but I don't think it'll be a long lesson. All right. So, I guess we're in Chapter 13. I'm sorry, not Chapter 12. So Chapter 13 on parametric. All right, so sometimes your data does not meet parametric assumptions. All right, so we saw the bell curve earlier where you've got the mean, mode, and median all kind of match up. Sometimes these things don't work out. We've got a curve here that's got a skew to it, a positive skew tail. So we don't have normal parametric statistics. So what do we do? Okay. So when to use parametric versus non-parametric. So if you have a normal distribution in the population, we use parametric. If it's skewed, kurtosis, or other, non-parametric. Variance, equivalent per group, parametric. Non-parametric, we can use on any, observational data, independent, non-parametric any, and then data type, ratio, interval on parametric. And then we can do non-parametric on nominal, ordinal, ratio and interval as well. Okay. So the types of comparisons. So when we're looking at relationships amongst variables, if we're doing a parametric statistical test, we'll use the Pearson product moment correlation. If it's non-parametric, we'll use Spearman's rho. Difference between two independent groups, parametric would be the t-test, non-parametric would be a Mann-Whitney U or a chi-square. Difference between two dependent groups, we'll use match pair t-test for parametric or Wilcoxon for non-parametric. Differences in more than two groups, one-way ANOVAs for parametric, Kruskal-Wallis or chi-square again for non-parametric. And repeated measures in more than two groups, we do repeated measures ANOVA or a Friedman test in non-parametric. So we'll talk about what these different tests are. So chi-square, right? So when you see this one, it's an X or a chi squared, right? Use when data are represented as frequency or percentage. Participants are groups in the categories. Trouble talking today. Compares expected and observed, right? Significance, we calculate the chi-square. And as long as the calculated chi-square is greater than the critical chi-square, then it is significant, right? So very similar to the parametric statistics we're looking at in chapter 12, right? A one-way chi-square, do two or more groups differ on one variable category? Example, coach wants to determine if frequency of ankle springs is different on old grass versus new AstroTurf fields, right? So observed would be AstroTurf fields, but the expected is a grass field, okay? So again, this data and chi-square calculation for frequency of ankle springs on grass versus AstroTurf field at Jock University, right? So you see the observed number of sprains. So on grass was 24, turf was 36, total of 60. Expected number of sprains was 30 on grass, 30 on turf, right? So the observed was higher on the turf versus grass, but expected was equal 30-30, right? So when we calculate, the chi-square was less than the critical chi-square at 2.4 versus a 3.84. So the decision on this one would be do not reject the null hypothesis, okay? Two-way chi-square, do two or more groups differ on more than one variable category? So again, we'll use a contingency table. So example, does field type, grass or AstroTurf, affect severity of the ankle sprain? So we're not just looking at whether or not they get the ankle sprain, but now we're looking at first, second, third degree ankle sprains, okay? So again, and if you're deciding between a one-way chi-square and two-way, it's going to be contingent on, are we looking at two or more groups differ in one variable category, or do two or more groups differ on one on more than one variable category. All right, so again, we had the grass or astroturf with just the ankle sprains. Now we've got grass or astroturf with first, second, and third degree ankle sprains. Okay, so correlation. All right, we're not doing Pearson product for non-parametric. We use the Spearman's rule. It's equivalent to and interpreted like the Pearson's product moment correlation. Used with small sample size or when dependent variables are either one ordinal or one continuous, or both are continuous, based on ranking of data. So again, we use a statistical P and the calculated P greater than the critical P for significance. So when should you use Spearman's P test instead of Pearson's rho? And again, check your understanding for how do you interpret a significant Spearman's P of 0.6 or negative 0.75. Right, so again, it's going to be the same thing. Right? It's anytime we do correlational data, right? The closer it is either to 1 or negative 1, the more, the higher the chance of a real correlation rather than chance of chance or the chance of a chance correlation based on errors of some type, right? Differences between two groups, the Mann-Whitney U, used when parametric assumptions are not met or group size is unequal, based on ranking of data. So we use a statistical U, and again, it's significant if the calculated U is greater than the critical U. So again, here's some examples of comparing 100-meter sprint times in standard versus specialized wheelchairs. Okay. And so the calculated U is greater than the critical U, so the decision will be reject and no, that actually there is a difference and they found a difference. Okay, and you can see we've got the less standard wheelchairs versus the Eagle Tornadoes. And so again, we couldn't use a parametric test because we had unequal grouping. Okay. Kruskal-Wallis, one-way ANOVAs, used when more than two groups are being compared and interpreted similar to an ANOVA. All right. That's it. It's really quick, kind of down and dirty, just getting into it. But again, it's just an introduction into the statistics. We won't actually, in our program, we don't really have the chance to actually do the research. And again, this is something that we've with the department chairs and everything. So, if it changes, we'll change text, change the way we do this. But again, intro, those of you going on to grad school, you'll get a lot more on this subject and how to do it. But that's it for chapter 13, and I'll see you guys again tomorrow.